Next example comes out of section 5.1. The section is called Graphing Sine and Cosine Functions, and in this first example we're going to actually draw y equals sine x. To do that, we're going to start off with a table of values. Naturally, you have a graphing calculator, so you do have some shortcuts to try to get yourself to these answers, but let's start also by doing it in degrees. Again, most of you, I think, are still more comfortable with degrees than radians at this point, and we'll draw it in radians afterwards. But if I put in some values for x, 0, 30 degrees, 45 degrees, 60 degrees, values where I can fairly easily find what sine of 0 or sine of 30, sine of 45, those are values that I actually know fairly well. Use all the numbers heading around the unit circle. Sine of 0 is 0, sine of 30 degrees is a half, which I'll just put down as 0.5 since I'll be putting it on a graph here. Sine of 45 degrees, sine of 60 degrees, sine of 90 degrees, etc. So we'll fill in this table. So just to save time, I filled in the table. These are numbers that your calculator will give you if you're in degree mode, or if you convert some numbers that you know off the unit circle. Sine of 30 degrees is 0.5, sine of 45 degrees is root 2 over 2, or 1 over root 2, which is 0.707. Sine of 60 degrees is 0.866, sine of 90 is 1, sine of 120 is 0.866 again. You start to see that you basically are getting the same numbers over and over, which will relate to what this graph is actually going to look like. So I've got some axes here, labeled x and y axes. We don't need to go any higher than 1, realistically, in the vertical direction, up to positive 1 or negative 1, but I made it go slightly further, and we're only graphing for the moment up to 360 degrees. So I made my scale here every 60, 60, 120, 180, 240, 300, and 360, just to save a little bit of space. Now, at 0, I have 0. That's an easy point to plot right at the origin. This graph y equals sine x goes through the origin. At 30 degrees, which is halfway between 0 and 60, I'm at 0.5. So I can put a point as accurate as I can. Now, 45 degrees is just slightly further than that, and I'm at 0.707, somewhere a little bit higher. At 60, I'm a little bit higher again at 0.866. At 90, I'm going to be at 1. As I go further along, I'll see that I start to repeat these values. I start to come back down, and I have 0.866, 0.707, and 0.5 again. At 180, I'm back down to 0. That's a nice point to plot. Now the values repeat themselves, but they do go negative, and so at 210 degrees I'm at negative 0.5, then I'm at negative 0.707, negative 0.866, at 270 I'm at negative 1. That's as low as this graph ever goes. Starts to come back up, and eventually back to 0 if you plot your points. Now if I just play connect the dots, I see the shape of a sine curve. They call this a sinusoidal wave because it looks like a wave. And it actually turns out that if I went further to the right or further to the left, I would just see a repeat of the same shape. It would go again, and to the left it would go again. And this graph does the same thing over and over and over because, as you know, the values of sine repeat themselves over and over at 0, 360, 720, etc., at 90, 450. Anytime you go 360 degrees past where you are, you get to the same spot. And so what we have here is a graph that has very specific characteristics. To fill some of these most important characteristics in, we have something called the period. Periodic function repeats itself every certain cycle, and so in this case it repeats itself every 360 degrees. The amplitude is basically a description of the size of these waves. They go from the middle, they go up 1 unit, down 1 unit, up 1 unit, down 1 unit, so the amplitude is 1. Well, once we start to have different amplitudes, we'll come up with a little formula for finding them. The domain is x, where x is an element of all real numbers. There's nothing outside of our domain. You can take the sign of any positive or negative real number and you can get an answer out of it. The range, however, is limited. Our y values don't go everywhere. They actually only go from -1 as the minimum up to +1 as the maximum. Other than that, all real numbers in between there are fine, but you'll never have a number higher than 1 or lower than -1. So that's a reasonably good job of a sine graph in degrees.